Hey guys, in this video what I want to happen is I want you to understand how to tell if an exponential function represents exponential growth or exponential decay by looking at the graph and looking at the equation. So what I've got here is a Desmos setup where I have an exponential function. That exponential function is y equals 1 times b to the x. The reason we're calling this b is that it stands for the base, also called the growth factor. And I've set up a slider here where I can change the base of my function. So right now that's set to 2. So this is the exponential equation, y equals 1 times 2 raised to the x power. And what we're going to do is we're going to change the base and we're going to see how this affects the graph. So right now when the base is 2, we can see that as we go left to right on this graph, the exponential function curves upward. And so it's getting bigger as the x values get bigger, that is, as they go towards positive infinity. So as we move to the right, the function is getting bigger. This is a situation called exponential growth. So when our curve is going up and up and up and up, and this will continue going up very rapidly, we call that exponential growth. And here's how you can tell from your equation whether or not you'll have exponential growth. You look at the growth factor, or the base. In this case it's 2. If the growth factor is greater than 1, we will have this situation where the graph curves upward, and this is exponential growth. So now we need to see what can happen to cause what's called exponential decay. So I'm going to adjust my base, and I'm going to turn it down. Remember, we can't have a base of 1, because when we have a base of 1, it turns into a linear function. But when I make my base less than 1, something different starts to happen. Here we can see that as we go left to right on the graph, it's decreasing, it's going down and getting closer to 0 as we go from left to right. This is a situation called exponential decay. So as we go left to right, if it gets bigger, it's exponential growth. If the graph gets smaller, like it's going downward, we call it exponential decay. And this happens in an equation when the growth factor is less than 1 but greater than 0. Remember, we're not allowed to have a negative growth factor, and we don't want a growth factor of 0, because then we just get a flat line from 0 outward. But if b is between 0 and 1, we'll have exponential decay. That is, the graph will be getting lower, closer to the x-axis as we go from left to right. And if the growth factor is greater than 1, the graph will get larger. It will increase going left to right, and that's called exponential growth. So in the next task, or in the task for this assignment, what you're going to be doing is you're going to be looking at some graphs, and you're going to be looking at equations and determining whether or not they show exponential growth or decay. If it curves upward going to the right, it's exponential growth. If it curves downward going to the right, it's exponential decay. In exponential growth, our base is greater than 1, and in exponential decay, our base is between 0 and 1.